Hey guys, I'm going to do 4 YouTube videos going over the Unit 1 review packet. So I'm going to start with page 1. Let's go ahead and jump right in. So skills 1A through B are these first 6 questions. Number 1 says, name 4 rays that use B as an endpoint. Well, if we look at this picture, B is the endpoint they want. We want 4 different rays. So we start at B and we can go in all 4 different directions. So let's start with ray BA. So we start at B as the endpoint. We go in the direction of point A. We have B going towards E, so we have ray BE. Since they go on forever in this direction, we have to put that arrow after the E. We have ray BC. And lastly, we have ray BD. Rays should always have 2 capital letters and a symbol that looks like this. Okay, number 2 says name line L 4 different ways. Here's line L. In order to name a line, we need to use 2 letters and a symbol that's a line with arrows going both directions. So let's pick any 2 letters we want. EB we could use, so we could have line EB. What this is saying is we have for any 2 points, there's only 1 line we can draw through those 2 points. So if we have point B and point E, the only line we can draw is this one. So that's why we can name it with just 2 points. Another option is just to change the order, so we could call it line BE instead of EB. And then we can choose 2 other points instead. We could call this line BD because this line also contains those 2 points. We could also call it line ED. When you name a line, you just have to use any 2 points on that line and use the proper symbol. Number 3 says 2 pair of opposite rays. And remember, opposite rays, when they're together, they just look like a line. So if we use line L like we did before, ray BE and ray BD together form a line, the 2 pieces of a line. And so our opposite rays are BE. Remember, we always start with the endpoint and then BD. Okay. Name 2 pair of adjacent angles. Now remember, by definition, adjacent angles have to be next to each other. So here is 1 pair of adjacent angles. We could do this angle here with this angle here. Notice they share this side and they share this vertex. That would make them adjacent angles. So let's name this one up here. This is angle EBA. And angle EBA is next to or adjacent to ABD. Angle ABD. There's a lot of options we can use for adjacent angles. Another example could either be this angle with this angle, or I'm going to do this angle as adjacent to this angle. So angle EBC and angle CBD. And I'm just going to put a little orange here so people know that that was what we did from orange, and this is what we did in green. Okay, let's keep going. Number 5 says 1 pair of congruent angles. Well, congruent angles are angles that have the same measure. And remember, we indicate congruent angles with the same number of arcs. So that has 1 arc, this has 1 arc. That's telling us that those 2 angles are the same. They're congruent. So a pair of congruent angles would be angle ABE and angle DBC. Remember, you could have named this DBC, or we could have gone backward and called CBD. It doesn't matter. Either way is fine. Number 6 says name 1 pair of congruent segments. Well, since this segment here, EB, has 2 tick marks, and segment BD has 2 tick marks, that's telling us that those 2 segments are the same size. So segment EB is congruent to segment BD. That just means they have the same length. Okay, now we have a couple true or false problems. Number 7 says if 2 segments are congruent, they will have the same number of tick marks. Well, that's exactly what we just talked about. So let me draw some examples really quick. We know that these 2 pieces are congruent. They have the same number of tick marks. If I were to draw this picture, these 2 parts would be congruent because they both have 2 tick marks. This one is different because it only has 1 tick mark. So this is true. 8 says this thing here, AB with a line on top, represents the length of segment AB. Well, that's false because we talked about how AB with the segment on top is talking about segment AB, and segment AB isn't a length, it's talking about a figure. If we want to talk about the length of segment AB, we just do AB without a line on top. It asks us to fix the statement so it's true, so that's why I made that change. Okay, number 9 says 4 points are collinear if they are all on the same line. Well, collinear means literally together. That's what the co means, together Linear literally means line, so together on a line. So 4 points are collinear if they're on the same line. Yep, that's true. Good. Okay, let's keep going. Here's skill 1C and E. Draw and label an angle to fit each description. Number 10 says a 60-degree angle named angle FOX. Well, we know that 90 degrees is when we draw this straight up here. 45 degrees is half, but we want 60. That's going to be a little bit more. So I'm going to do a little bit more than 45 degrees. That's 60. And then this is going to be angle FOX. Number 11 asks for a right angle. So a right angle is like a perfect corner. We put that little box, that means 90 degrees. And this is going to be angle CAT. Okay, on to 12 through 14. We're just going to be naming some angles. So if we look at this picture, we need to name an obtuse angle. An obtuse angle is larger than 90 degrees. So this angle here is an example of an obtuse angle. It's larger than 90 degrees. So angle SMV. We could also get an obtuse angle on this side by covering this piece up and have UMR or RMU. I'm going to list multiple examples just in case, depending on the one that you might have picked. Okay, a straight angle is literally a straight line, so angle RMV. This is our vertex, so angle R to M to V. An acute angle, we have a bunch of them in this picture, so something less than 90, so RMS is an example. SMT is an example. TMU is an example. And UMV is an example. Okay, so those are some examples of different types of angles and naming them. Okay, that's the end of page 1. Stay tuned for a video on page number 2.